All right, so now we're going to talk about polyatomic ions. This is a special group of ionic compounds. Poly means many, and then atoms, and ions mean they have a charge. So polyatomic ions are lots of atoms put together that carry one charge as if they were one thing. So these are on page 7 of your reference tables. So you do not have to memorize them. What I do suggest doing is going through and putting parentheses so that the subscript, that little 4, is on the inside and the charge is on the outside. So ammonia is NH4 plus 1. Bromate is BrO3, and then on the outside, minus 1. Cyanide, Cn, minus 1. Acetate can be written either way. C2H3O2 is the way I prefer to do it, and the negative 1 is on the outside. Perchlorate, ClO4 minus 1. Chlorate, ClO3 minus 1. Chlorite, ClO2 minus 1. And hypochlorite, ClO minus 1. So notice all 4 of those are all chlor something. So you have to make sure that you're matching the correct word to the correct formula. Then we have iodate, IO3 minus 1, permanganate, MnO4 minus 1, nitrate, NO3 minus 1, nitrite, NO2 minus 1, hydroxide, OH minus 1, hydrogen carbonate, HClO3 minus 1, hydrogen sulfate, HSO4 minus 1, thiocyanate, SCN minus 1, and then we have some charges that are not 1. We have carbonate, which is CO3 minus 2, dichromate, Cr2O7 minus 2, chromate, CrO4 minus 2, sulfate, SO4 minus 2, sulfite, SO3 minus 2, and then phosphate. So again, the parentheses are keeping everything that is, we're considering one item together, and then the charge is on the outside. The charge is the superscript. The rules that we use to name binary still apply. So we're going to name the first thing first, and then the second thing second. So calcium off the periodic table. And then here we have this polyatomic. We know it's a polyatomic because it's in parentheses. So all we need to do is go find OH on our list of polyatomic ions. So we look. It is right here. OH is hydroxide. So this is calcium hydroxide. We don't have to do anything to that name. For polyatomics, you simply copy the name off the list. In number 2, we don't have parentheses, so how do I know that there's a polyatomic? That's because there's more than 2 capital letters. So we're either having Na2C on our list on page 7, or it's CO3 that's on our list on page 7. And in fact, it is CO3. It's sitting right here, which is carbonate. So if you want to, you can throw parentheses around there. So Na is sodium, and we simply copy the cation. And then the polyatomic is carbonate, and we simply copy down the polyatomic. So you're not changing the ending of any of these names. We're simply matching and copying the word. When we go to write the formulas, we're still crossing our charges. So barium is Ba2 plus on the periodic table. And then we have sulfate. Ate tells us it's a polyatomic. So if the end is Ate or Ite, it's a polyatomic, and the few exceptions we have are ammonia, which is our only cation, cyanide, and hydroxide. All the other ones end in either Ate or Ite. So Ate tells us it's sulfate, which is all the way down here towards the bottom. So SO4 in parentheses, the 2 minus on the outside. And then we're going to cross our charges. And so we have Ba2 SO4. Notice that the charge for barium is being crossed to the outside of the parentheses. We never change what's on the inside of the parentheses. But what we can do is we can reduce the 2 and the 2. So the real answer here then is just BaSO4. You can have the parentheses there if you want, but because there is nothing, or because the subscript is now a 1, you don't need the parentheses. So I would just write BaSO4. The next one, we have ammonium. That is our only cation that is on our list of polyatomics. So don't look on the periodic table for ammonium, you won't find it. It is the very first thing listed on our polyatomics, way up here, and it is the only cation that we have to know. Phosphate is at the bottom of our polyatomic list. So in parentheses, PO4, 3 minus on the outside. So when I go to cross my charges, the 3 is going to come down and the 1 comes down to the outside of the parentheses. So we have NH4, 3, PO4. The PO4 doesn't need parentheses because we crossed a 1 down. If you write them, it's fine, it's just not needed.